Welcome to Sundar's lecture. This is lecture number 22, and in this lecture we are going to see demultiplexer and then encoders. Both we are going to see. See what are all the topics we have seen in the previous class. That means in 21st lecture we have seen decoders with enable inputs, right? So what an enable input will do with the decoder, right? So if this is input and this is the output, and if you use 0 0, the first output will be enabled, right? So before that, if this enable input should be high so that the decoder will work. If the enable input is 0, then obviously whatever the input you are giving, the output will defaultly become 0. So that is what we have seen, and the logic diagram of enable input decoder, and we have seen how to implement 3 cross 8 decoder using 2 cross 4 decoder, and then also we have seen full adder using 3 cross 8 decoder and 2 cross 4 decoder, and we have seen how to implement 4 cross 16 decoder using 5 2 cross 4 decoders, right? So if any problems, Boolean expression problems has been asked to implement 4 input system using 2 cross 4 decoder, then you have to follow this one. Very simple. You just put whatever the if it is an SOP function, then whichever the output is high, just put it in an OR gate, right? That is how you need to understand, right? So this is what we have seen in the previous class. Now in this lecture we are going to see demultiplexers. What is demultiplexer? A demultiplexer steers the input to one of the many output based on the control input. For example, what is this one? It is 1 to many. We generally have an expression like 1 cross 2 power n. And what is this one actually? This one is an input. This is input, and this whole thing 2 power n is output. Try to understand, right? So this is output, and you know, right, what is this n separately? This n, which is the selectors, right? This is the selectors, and this is how a decoder will looks like. For example, we will take a 2 cross 4 demultiplexer. Maybe I will, in short form, I will write it as demux. So what is demultiplexer will have? See, try to understand. If this is the demultiplexer, and we have like this, for example, it is 2 cross 4 demultiplexer, right? Sorry, not 2 cross 4. Maybe I made a mistake. It is 1 cross 4, right? Always you have 1. So 1 cross 4 demultiplexer. Then what is this one? This is actually 1 cross 2 power 2. That's all, right? So 4 outputs will be there. Obviously, for an obvious reason, you will have 4 outputs: 1, 2, 3, and then 4 outputs will be there. How many inputs will be there? Only one input. Try to understand. That is the idea. One input will be there. And how many selector switches you will have now? You will have 2 selector switches. This is the selector switches. So in general, we will call this as D input, and this is Z0, Z1, Z2, Z3. This is the outputs, and S0, S1. This is the selector switch, and this is nothing but 1 cross 4 demux. Right? Can you understand? This is the whole idea. And what this demultiplexer will do? This input will steer to output, which means this whatever the input you are connecting here, D is equal to 0 or 1, that will goes to any one of this output that depends on this selector switches. For example, if I put this is S0 and this is S1, and what happens to Z0, Z1, Z2, Z3? That is the idea now. And I will put the tabular column. See this, if S is equal to 0 0, if S is equal to 0, S0 is equal to 0 and S1 is equal to 0, then what happens? This D will be connected to this Z0. This will be connected to this Z0. So what happens now? This will get D and all other outputs become 0 simply. And I will go now fast. If it is 0 1, then if it is 0 1, it is at 0 0. If it is 0 1, then it is connected to here, and this will be 0. Only Z1 will get D, and this are 0. And what happens if we connect 1 0, 1 0 to S1, S0 and S1? This will come here. This is 0 1, and this is 1 1. Sorry, 1 0 1 0. So you will get 0 0 D and then 0. And if you give 1 1 1 1, what happens now? This will come to this output. This is nothing but 1 1. So this will be 0 0 0 D. Simply this input will be steered to output that depends on selector switches. That is what we have written here, right? So what we will do, this is the demultiplexer. Simply, this is the demultiplexer, and what is inside this demultiplexer? That is what we need to understand. And this is the understanding, right? What is this one now? Maybe this is D input. Maybe I will generally write it as D in or D, whatever it may be. See, if it is 1 cross 8 decoder, then what is the idea? It is 1 into 2 power 3. So 2 power 3 is 8. So 8 number of outputs you will have. So here you have 8 number of outputs and 3 selector switches you will have. So 3, which means this is inverted switches, inverted switches. So what will happen now? If it is 1 cross 8 decoder, this input, this D in should go to output that depends on the selector switches. For example, if you give selector switches 0 0 0, then what happens now? S0, S0 bar, S1 bar and S2 bar becomes 1. All these three, see here, this is S0 bar, this is S1 bar, this is S1 bar, and this is S2 bar. Everything is connected to first input, first AND gate input. So this D in is connected here. So obviously these three becomes 1. And whatever you give in D input, maybe it is 1 or 0. If you give 1, the 1 will be transferred to output. If you give 0, this 0 will be transferred to output. Simply, right? So what happens here? So if you give 0 0 0, this D in will be transferred to Y0. I have written Y0, Y1, Y2. Maybe you give different names as an output. So if you give 0 0 1, then you see this becomes 1, this becomes 1, and then this is 1, 0 0 1, direct 1. That is connected to the second AND gate input. So this becomes 0, and this D in is directly connected here. So this will be transferred to the output. Now all other AND gates will become now 0. Any one of the input becomes 0, so that the output of the AND gate becomes 0. So simply this is the logic diagram of a 1 cross 8 decoder, right? 1 cross 8. If it is 1 cross 16 decoder, then you will have 16 number of AND gates, and the same thing will happen, right? So those kind of things you know. And how to implement a 1 cross 4 demultiplexer using 1 cross 2 demultiplexer. And now what we are actually doing, we are getting the higher order demultiplexer using lower order demultiplexer. For example, this is Y0, Y1, Y0, Y1 they have written. So this is the 1 cross 2 demultiplexer. You know, one input and 2 outputs are there. Since it is 2 power 1, so you will have one selector switches. That is what in every demultiplexer has been written here. So in general, we need to implement 1 cross 4 demultiplexer, right? So how many outputs you will have now? Z0, this is Z1, and you will get Z2 here, and this is now Z3. Simply you will get like this now. And how you need to give the inputs now, how you are going to give the selector switches. So these selector switches we can give this is S0 and give this as S1 and S2. For example, if it is an 1 cross 4 demultiplexer, that is what we have seen here. See here, this is actually 1 cross 4 demultiplexer. That is what I have taken here. Maybe I will take this to the other page, this truth table. See here, I have just taken this truth table now. So if you maybe this input you have to understand, I give D here now. So what will happen around now? So if I give 0 0, so this is 0, and as well as this is 0, this is 0. First condition I will explain you. If this is 0, then what happens? This D will be, maybe we need to connect this one also. So how will you connect this? This output will be connected to here, and this output will be connected to here, right? This is how you need to connect the multiplexers. And if I give 0 0, then what happens now? So what happens now? this is 0, this is 0, this is 0. If this is 0, then this D will go here. So I will make this as now D. This D will be transferred to this output, and this output will be 0, right? So now this will be D, maybe I for the first input, maybe this is D, now this is 0, and this is now 0. So if this is 0, then this D will go here. So what happens now? The output becomes now D for the first input, and this is 0. And since you have given 0 here, this S1 is now 0. So this 0 will be transferred to this output. So this will be 0. This is not connected, then I will write down here this will be 0. So what you are getting for Z0, you are getting D, Z1 0, Z2 0, Z3 0. That is what we have written here simply. So if I give 0 1, then what happens? So S0 is again 0, but S1 becoming 1 here. Yes, sorry, S2. This is S2. Oh, I have written like this. Oh, so this is S1. This is S1. Anyhow, maybe I will write it down. This is S1, and what we have given, this is 0, right? First time we have given this as 0, and now this will become now 1. So this condition, we have came to this condition, S0 is equal to 0, S1 is equal to 1. So if it is so, then again what happens now? This is 0, so this D will be again connected here. This is again 0, simply, right? So if this is 0, maybe we will go here, this D will come here, but since the S1 input is 1 here, selector switch is 1 here, this D will be transferred to this one now. So what happens here? This becomes 0, and I will write this one here. So this is already 0, now it becomes now 0, D, and this 0 will be transferred to this one. Since this is 1, obviously this becomes 0. This, if this is 1, then this input will be transferred to this output. So this is also 0. And if I give 1 0, so what happens now? S0 becomes 1, S1 also 0, and this S1 becomes also 0. So if this is 1, then what happens now? This D will be transferred to here. So this becomes 0, and this becomes D now. So if this is 0, so this is already D, now this becomes now 0. So if this is 0, then this is 0, so this 0 will be transferred to here. So if this is transferred to here, this will be obviously 0. Then this D, since this is 0 now, this D, this is already 0, this D will come here. So this will come as D now. So this is D now. So this is 0. So what happens now? This D will transfer to this output. So what happens here? This will be D, and this output becomes 0. Simply. Right now, what is the other thing I can do here? For the last input, this is 1. So that S1 is 1. This is also 1. So what happens now? If this is 1, then obviously this output becomes D. This is 0. So this is 0. This is now D. So whatever it may be, you give 1, what happens now? This will be 0, this will be 0, anyhow this is 0, right? So simply, so this is now D. What happens now if I give 1 here? So this output becomes 0, this output becomes D. Simply you check it out, you will get this one, right? So what we have done now, I've just explained how it is working now. So we are using only 1x2 demultiplexer, but what we have implemented here, we have just implemented 1x4 demultiplexers output. This is how you need to connect. So what you need here, you are required 3 1x2 DMUX to implement a 1x4 DMUX. So if you want to implement a 1x4 demultiplexer, 1x4 demultiplexer, you need to have 3 1x2 demultiplexer, right? So this is how you need to connect. Anyhow, I'm not going to explain the exact procedure here in the next one. What we are going to do now, we are going to implement 1x8 demultiplexer using 1x4 demultiplexer and 1x2 demultiplexer. Now you see, this is actual things, right? From Z0 to Z7. Maybe this is Y0, Y1, Y2, Y3, and this output is Y0, Y1, Y, this is Y2, this is Y3. This is the output of 1x4 demultiplexer. This is the output of this 1x4 demultiplexer. This is 1x2 demultiplexer, so it has the output of Y0 and Y1, right? So what we are going to do here, since what we this output, maybe what is the truth table for 1 cross 8 demultiplexer. So if it is an 1 cross 8 demultiplexer, then obviously you will have 3 selector switches, right? S0, S1 and then S2. You will have 3 different selector switches, and depends on these 3 selector switches what will happen now. Z0, Z1, Z2, Z3, Z4, Z5, maybe you don't have space, Z6 and then Z7 will be there. If it is 0, 0, 0, then what happens now? Z0 gets D. And if it is 0, 0, 1 means Z1 should get D, and this every other output should become 0. That is the whole idea. I'm not going to do everything, but this is the idea. And how you need to connect this one, that is what I'm going to do now. You put this as now D simply, and what you do, you make this as S0 and make this as S1 and then S2. Simply what we have done in the previous thing, you have to follow the same thing. And the simply what you do, you just take a point from here and you just connect it here. Take a point from here and you just connect it from here. That's all. That's all. What we need to do, this is the selector switches S0, S1 and S2, and you are getting 8 number of outputs here, 8 number of outputs, right? So what we have done now, we have just implemented the 1 cross 8 demultiplexer using 1 cross 4 demultiplexer and 1 cross 2 demultiplexer. So if you want to implement 1 cross 8 demultiplexer, what you need 1 cross 4 demux. How many numbers you need now? How many numbers you need? This you need 2 numbers. And 1 cross 2 demux, you need have 1. You need to have 1. So this is how you can implement. Anyhow, you can also replace this 1 cross 2 demultiplexer as a 1 cross. If you have only 1 cross 4 demultiplexer, then what you need to do? You just put this 1 cross 4 demultiplexer and then you connect both inputs simply, right? You just go get to the Google and you ask that, it will tell you how to get the lower order demultiplexer using higher order demultiplexer. That I am not going to explain you because that is very simple. So this is the connection, right? So this is how you need to implement, right? So if they are asking you any problems, maybe we will have some problems. Very simply, you will have, see, implement a full adder using 1 cross 8 and 1 cross 4 demultiplexer. How will you do this one? So simply, what you do now, this you make this to be 1. So you need sum separately. You need sum separately, right? So this is sum, and then you need carry separately, right? So this is now carry. Maybe I will write it out. This is sum and this is now carry simply, right? So what we will do now, you make this as now A, B, C inputs, you get this to 1 now, and we need to connect this minterm straight away, this one. So what you do now, you get this one, and you just connect it out here. Maybe I will do that and I will tell you, right? See here, this is the diagram simply, right? So you have to connect this minterms. For example, if you give 0, 0, 0, what happens now? This one will be connected to y0. So this y0 is not connected to sum and carry. So sum becomes 0, carry becomes 0 simply. If you give 0, 0, 1, this one will be connected to y1. So sum becomes 1, carry becomes 0. So you just verify the truth table of the full adder by using this one. You will get it down. Anyhow, this is very simple, right? This is very simple. 1 cross 8 is very simple. And what you need to do, you have to go to now, you have to implement using maybe the question is like you have to implement also using 1 cross 4 demux. So if you want to implement 1 cross 4 demux, then you have to connect like this, right? And we know this one already, how we can do this one. You just, maybe I will connect it down and I will tell you. See, you just connect these two now, these two outputs to this D input, maybe the input of the demultiplexer, and give this D is equal to 1. And how will you give the input now? This has to be A and this has to be B, this is C, this is B and then C. Simply now what happens? The 1 cross 4 demultiplexer and this 1 cross 2 demultiplexer combinedly gives the output of 1 cross 8 demultiplexer. Simply what you can do now, just put the same diagram here. That's all. Very simple. Now you see, this is the sum and this is the carry. Simply you put D is equal to 1 and ABC here. You will get the output of full adder, right? So this is how you need to implement it. So now we will see what is encoders. An encoder is a digital combinational circuit that converts a human friendly information into coded format for processing using machines. For example, it will convert the human friendly information into coded format, right? Like if you are having any decimal numbers, that decimal numbers can be converted into binary coded decimal numbers. Decimal to BCD, that can be converted using the encoder. So what is encoders? The applications of encoders can be data transmission, can be used in data transmission, controlling and automation, communication and signal processing, right? So what is the block diagram of the encoder? It has n number of inputs and m number of outputs. It has no certain principles like 2 power n or n into 2 power n, not you don't have any certain principles. You will have n number of inputs and then n number of outputs. So how many number of inputs you need, you just put it as an input, and how many number of outputs you expect, you just put that as the expected output. But the thing is, you need to get the coded output, right? So for example, we will go for now decimal to binary coded decimal encoder. For example, these are all what? So I will put this here. So these are all what? The binary, the decimal values, right? From 0, 1, 2, 3, 4, right? So for example, you need to convert this decimal to binary coded decimal. What is binary coded decimal? It will have from 0 to 9 as 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, and it will have up to 1, 0, 0, 1 as 9. So what it will do now, if you press this 0, this high, which means this is nothing but it is 1 now. So it has now 9 switches here. This is 1. So if this one is connected to this pin, this is not connected to anywhere. So what happens now? This D, C and then B, A, the output will be 0, 0, 0, 0 for the input as 0. For example, if you press this one, what happens now? This one is connected to A. This is OR gate. So what you will get now for this DCBA, like you will get 0, 0, 0, 1 for input 1. That means 1 means the decimal value, right? So this is how you will get up to, for example, you get 0, 1, 0, 1 if you press 5. For example, you check it out, this 5. What is this one now? This is DB, this is DCBA. So C will be 1, C will be connected, and then A will be connected to the OR gate. See here, C is connected and then A is connected. Like that, if you want to get DCBA as 1001, then it will be 9. So D will be connected and then A will be connected. So D will be connected here, A is connected. Nothing other things will be connected. So you will get this one. So this is the coded output. We have got it as an output. But what is the thing happening around here? For example, if I press this one and then I take it out and then I press 2, then no problem. For example, if I press 1 as well as 2, what happens now? If both switches are pressed simultaneously, then the I will get 1, 2 input in these two switches are connected, so that this will get high, this also will get high. So what happens now? You will get 0, 0, 1, 1, 0, 0, 1, 1. That is not a desired one. If I press 1, what should I get for 1? I should have got 0, 0, 0, 1. But if I press 2 simultaneously, I will get this output. So actually, this is a wrong one. I should not get a wrong answer, right? Why? If any case, if I press 2 switches simultaneously, I will get a wrong answer. So for that, what you need to do, we will go to the next page, as that is the topic now. It is priority encoder. Right, so what is a priority encoder? So here in priority encoder, what it will be now, this D3 will get highest priority. For example, we will take a simple example to understand how circuit will come. See, it has an higher priority. If I press D3, these four are inputs, and these two are output, right? So if I press D3, then obviously my C1 and C0 becomes 1. Whatever the inputs D2, D1 and D0 are connected to either 0 or 1, I don't need to care. If I press this one, then I have to get this as 1, 1. And if D3 is 0 and D2 is 1, then I should get this as 1, this as 0. And whatever the inputs for D1 and D0 I am giving, I should not care about that one. Like that, I am just given, I have just given you the 4 inputs like this, and I need to draw the diagram for this now. For drawing the diagram, what you need to do, you simply put this values in Karnaugh map, get the minimized Karnaugh map expression, and draw the logic diagram simply, right? So what you can do now, see here, for this one, this is 0001, right? So 00 and then 01, this is 00, D3, D2, D1, D2. I have just drawn the Karnaugh map of separately C1 and C0, 0001, so 0001, so this has to be 0, this has to be 0, maybe I will take a different color, so this has to be 0, and what is the other thing? See, this one we need to write it down. For this one, I'm just writing down. It is 0010. I can put x is equal to 0 at one time, and then 0011. I can put these two, right? So at that time, I'm just writing it for C1 here, C1. So for these two, I should get what? 0. So 0010, it is 00011. So 0011, I should get 0 here. And what is the thing here? That's all right. So this one I have got it down. For this one, I am going to write down with this color. What I will get now, it is 0 1. For these two x, put 0 first, and 0 1 0 1, and then 0 1. This is fixed one. This is fixed. This 0 1 is fixed. For this x's, you put combination. How many combination you will get? Obviously 4 combination, right? So 1 0. This will be now 0 1 1 1. For these 4, I should get 1. That is what they have written here. So 0 1 0 0. 0 1 0 0 is here. So you should get 1 for this one. And 0 0 1 0 1. So you should get 1. 0 1 1 0, you should get 1. And then 0 1 1 1. 0 1 1 1. You should get 1 for this also. So for this one, I have written, I am going to write with a different color. I will write it in this color. For this, what is happening around, you will get 1. For these 3, you need to put the values. For 3 combination, what you will get? 0 0 0 0 0 1. So you will get like this. So 0 0 0, this one is constant, 0 0 1, and this one is constant, 0 1 0, this one is constant, 0 1 1, and you will get this one is constant, 1 0 0, this one is constant, 1 0 1, this one is constant, 1 1 0, this one is constant, 1 1 1. For all these 8 combination, I will get, I should get this as now output of C1 should be 1. So what I will put down, so this is nothing but here, right? So 1 0 for all combination and 1 1 for all combination, 1 0 and 1 0. So you will get, you just put this, you will get like this, right? That's all. So what is this one? This is x. I don't need that combination. So you simplify this one. What will you get down? So if I do, I will form an octet like this, right? So this will be an octet, right? This will be an octet, and the another one, this will be considered. These one should be considered. So this can be made as another octet. So what is the output equation should I get here? So C1 should be is equal to, for this octet, what is the common term in these two? D3. So D3 should come plus, and what is the common term in these two? D2. So simply for C1, I have to write it as D3 plus D2. That's all, right? So for this one, I am not going to tell you. For this output, you just write the combination like this. I will put down direct values here. So I am getting like this now. So what you do now, you can connect this one as another group. So you do by yourself, you will get it down. So again, what it will be now, these two ones should be covered as a quad like this. So I have covered all the ones. So what is the output equation I will get now for C0? The common term here, it is D3 plus, what is the common term in these two? It is D2 bar, D2 dash, I can write like D2 dash, and what is the common term in these two? It is D1. So simply I will get an expression like this. So C0 can be written as like this, right? So I have found what is C0 and C1. What you can do now, you just put this as a diagram, and you see this is what you will get it as a logic diagram. And for this particular truth table, this is the diagram now. So even if you press, if D3 is 1, see here, if D3 is 1, then whatever you give as another input, you will not, that is not going to affect the output right here. Try to understand, right? How? See here, if D3 is 1, then this is going to here, and this D3 is going to here simply. So obviously this is now C1 and this is now C0. Obviously both becomes high irrespective of what is the input given to D1, D0, D2. That is the idea. And if you give 0, 1, this is mandatory condition. If you give 0, 1, if this is 0 and this is 1, what happens now? This is 0 means this will be connected to this OR gate, and this is 1 means then this is connected here. So obviously what happens here, this will obviously get the output as the 1, but if this is 1 then this will give you 0 here. So this output becomes 0, this is already 0, so this output will not come. So try to understand, you just check it out, this conditions with this diagram you will get it out, right? This is the priority encoder, right? So you will not get any errors in the output. So what are all the topics we have seen in this class? See, we have started with the demultiplexers. What is demultiplexer? It steers the output input to the output with respect to what is the given selector switches, right? So this is the 1 cross 4 demultiplexer, and this is the logic diagram of 1 cross 8 demultiplexer, and we have seen how to implement a higher order demultiplexer using lower order demultiplexer. That is what we have drawn here, and we have verified with every selector switches input and how the outputs are coming. And then we have seen how to implement 1 cross 8 demultiplexer using 1 cross 4 and 1 cross 2, and we have implemented full adder using 1 cross 8 and 1 cross 4 demultiplexers, and we have seen what is encoders, and encoders, how to convert this decimal numbers into binary coded decimals by using encoders. And we have seen there is a problem if there is no priority given, so how to give the priority and how that priority encoder is working. We have taken a simple example to understand this. So this is what we have seen in this class. So thank you. We will start a new topic in the next class.